present in the wine. So I'm going to draw this. This right here is going to be, that's going to be our flavor. That's simple, right? We'll call this the flavor. This could be the scent of an apple. This could be the scent of banana or pear. It's just an aroma compound, right? There are certain aromas that are obvious in a primary aroma of a wine. They come from the grape as soon as the wine is in bottle. You know, it's got a lot of fruit. There's stuff there. But there's a lot of stuff that's there that you can't smell, and the reason is because it's attached to, well, we're going to call this my sugar molecule. It's been a while since I've done this.
Hey man, I'm your sugar molecule.
Don't worry too much about this. This is a glucose molecule. I love to draw these kind of things. Representation. So in wine, what happens is you'll get this bond. You're going to have your flavor aroma molecule, but it's stuck onto a sugar molecule, so you can't smell it. It's like it's dissolved in the wine and it's just bound here. So it's not, you can't smell it. It's there. So what happens is with time, this is called a glycoside. Glycoside is glyc from glucose or sugar, and I don't know what the side is. But so some of these are bound already, and you can see under the release of bound aroma components. And what happens is with time, some of these are going to be hydrolyzed, which means they're just cut off from the glucose. It could be an enzyme that does that. It could just be a natural chemical reaction that occurs. So over time, you know, you may have other sugar molecules. I'm going to simplify it. And you may have a different flavor. Instead of this one here, it's this one here. You know, there are hundreds, maybe thousands of these in the wine. And over time, slowly you get this hydrolysis, and these things are then released, and they're able to come out up into the aroma. So this is one source of why a wine changes, why the flavor changes over time. And these happen at different rates. It's not like one day all of a sudden they're all released and the wine smells different. You know, some of them are released quickly, some of them could take years. Another source of aromas would be the formation of esters, which Chad talked about quite a bit. The difference here is that what we have is we have our flavor molecule. Actually, no, sorry, that is incorrect. We have one molecule, which would be an alcohol. Alcohols always end in an oxygen, hydrogen, and then you have an aldehyde. Or no, an acid. Sorry. Look at this. It's been a while. You have an acid. Don't worry about this. But what happens is they come together, they react, and what they do is they give off water, H2O. So the H from here and the H and the O from here come off as water, and they get stuck together, and it becomes one molecule. It becomes an ester. The point is that ester has a flavor. It has its unique flavor. And if you go to the next page, or actually it's on this page, I just put this chart in here because I thought it was kind of interesting. This is just some common esters that you might find in a wine, and it kind of shows you the structure, which is not really important at all. It shows you the name, and it shows you what it might be perceived as if you smelled it. And I only put the ethyl esters because ethyl means it came from ethyl alcohol, right? So there's a lot of ethanol in wine. That's the primary alcohol yeast produce. So this is what happens is that ethanol is reacting with some other acids, like, first example, acetic acid would react with ethanol and you get ethyl acetate. Second one, butyric acid reacts with ethanol, you get ethyl butyrate. The point is you have different acids, different alcohols, they react, and you get all these flavors. So there's really a whole other world of potential aromas that may not have been there in the primary young wine, that over time you can get more of these things occurring. So this tends to, again, explain why a wine matures in flavor and develops with time, where the bouquet comes from, right? And then a third and sort of important one, although I didn't go into it too much, would be the oxidation of existing aromas. John talks quite a bit about this.
Hey, before you go for it,
yeah, sure.
Then why wouldn't this happen to the same wine at the same period, at the same time every year? You know what I'm saying? If you're saying that, you know, the alcohol and the acids will release a flavor, or like I said, like that one flavor will release.
Yeah.
The winemaker can't control that, can he?
No.
At all. So regardless of the vintage, regardless if he's been making that Cabernet or that Chardonnay for 1,000 years.
No.
They happen on their own when they want to happen, and there's no. The winemaker can't control that through any type of chemistry.
You can't control it, but what
to
you
bring
can
certain
do.
flavors out.
Well,
You know what I'm saying?
in some way you can, because don't forget, any chemical reaction, this is a general chemical principle. Chemical reactions, the speed at which they occur is determined generally by temperature, right? So that's why we store our wines cool, right? So if you take your wine, you leave it in the car in the heat, and it gets hot, all those reactions are speeding up. And reactions that may not necessarily occur at a different temperature are going to occur. So you have some control. Light, the clear bottle, right? The curse of the clear bottle. The consumer loves it and we can't stand it because it just shortens the lifetime of a wine. Light, again, when it goes through the bottle, it tends to break things apart. It tends to maybe help catalyze the other things coming together. So there are some things you can control, I guess, if that's what you mean.
So if I had a 97-point wine, now I can't duplicate that. Can a winemaker? And then obviously they don't, but through chemical reaction and through all that, they can't control any of that to make that wine be cookie cutter every year. Same
No.
wine, same thing though.
Oh, and then especially if you consider that wine is a natural product, so
Right.
it's really the input, right? The input is where you get the potential for these things to happen. So every year, what's present in the fruit depended on the vintage, and so
I'm just curious. I was curious.
Yeah.
You can't manipulate any of that.
not really.
No.
No.
It's pretty much natural when it happens when it happens.
I wouldn't say, I think they're working on that sort of thing, right? There's those companies out there that are trying to determine what it is that makes a wine successful and get a big score, and then hopefully they can maybe add some of those things to wine, right? But once the wine is in the bottle, there's not much you can do other than store it properly. This is just going to happen. And the third point was oxidation of existing aromas. This is I have this little pet peeve where people, they get a bottle of wine and they say, you gotta let it breathe. And they pull the cork out and they put it on the counter and they let it sit there. And they're like, you gotta let it breathe. I hate when people do this. And I don't want to ever talk down to people, just like average Joe, right? You gotta let this breathe. When I'm at wine shows all the time, people drive me nuts. I think you need to let this breathe. I'm like, oh. So they're like, pull the cork and let it sit. Well, if you pull the cork out and let it sit, nothing's really happening. I mean, a little air is coming in and touching the surface of the wine in that little neck. It's not doing anything. The way to get air into the wine is to pour it out and get that oxygen bubbling in, and then it'll dissolve in the wine. That's how you're going to change things. That's why we decant them, right? Or Chris's little device, and we pour it through, and it bubbles. That's the way to get to aerate your wine. But when you do that, well, actually, in bottle, it's going to happen naturally because there's some air in that headspace.